Welcome guys. So in this video, I prepared notes to talk about an interesting topic called master theorem in computer science. Okay, and I want to use the more mathematical way to prove this theorem. So let's quickly see it. Okay, so the master theorem says that if t of n is a t n divided by b plus f of n, so we need to assume that a and b are both greater than 0. Okay, and also a should be greater than b. Okay, okay. So this NC, let's say it's called critical exponent or something. That NC is defined to be log BA. Okay, and this, let's say f of n is a polynomial, so it's theta NC. Okay, so if NC greater than C, then one can show T of n is theta n log BA. So basically, T of n is approximated n log BA. Basically, this term will dominate this term. Okay, and if NC equals to A, then NC equals to C, then it's very amazing that it becomes n to the C and take a log n. So these two are the same contribution. There will be log n. NC less than C, then this term will disappear and this term will dominate. So it's theta n to the C. Okay, now I will show an amazing fact that actually this is the master theorem. So if you take from I from a to 0 to n, xi, it becomes this. And for n very greater, if x less than 1, you get 1. X greater than 1, then you get xn plus 1. If x is 1, you get n. So I will show that this is the actual master theorem. So the master theorem is just a very beautiful camouflage of this, like the junior high school. Okay, maybe senior high, maybe like a junior high school results. Okay, so the computer science people very good camouflage. Okay, so before we start, let's talking about 3 stupid example, and hopefully you can get the idea of the proof. Okay, so the first example is stupid. T of n is just 2t n divided by 2, so t of 2 is just 2t1, right? T of 4 is just 2t2, so it's 41. T of 8 is 81. Okay, so t of 2 to n is 2 to nt1. So I let 2 to the small n to be capital large N, so it's t of large N equal to large N t of 1. So t of 1 constant, right? So it's theta n. Okay, so if you see this example that now c is 0, nc is 1, so the result will be nc. So n is like a n. Okay, let's say a famous merge sort. T of n is 2t n divided by 2 plus n. So t of 2 is 2t1 plus 2. T of 4 is 2t2 plus 4. So it's 4t1 plus 4 plus 4. T of 8 is 2t4 plus 8. So it's 8t1 plus 8 plus 8 plus 8. So if you see that, so you can see T of 2n is 2n T of 1 plus 2n times n. So for example, if n is 3, you get T of 2 to T of 8 is 2 to the power 3. 8 T of 1 plus 8 times 3. Okay, so T of 2 to n is 2 to n T of 1 plus n. So 2 to n it becomes n. So T of n is T1n plus n log n. Right, so this is n is log n, right? So T of 1 is just who cares, right? T of 1 is a stupid guy, so you're just kidding it. So because this is constant n, this is n log n, so the answer will be theta n log n. So this is the middle case. Okay, so let's talk about the third case. So these 3 examples just give you a feeling, and after we talk about these 3 easy examples, we can go to the proof. And amazingly, it's master theorem just a camouflage of some junior high school math. Once you understand the trick. Okay, so oh, by the way, be sure to subscribe to my channel. So T of n is 2t n divided by 2 plus n squared. So T of 2 is 2t1 plus 2 squared. T of 4 is 4t1 plus 2 times 2 plus 2 times 2 squared plus 4 squared. T of 8 is 81. So you just times 2, right? And then plus 8 squared. So you can go to the t to the 2 to the n, and you see that it's 2 to the nt1 plus the 2 to the n squared plus 2 to n minus 1 squared times 2 to n minus 2 squared times 4, and then up to here. And this is a geometric series, and the starting point is like at 2 to n plus 1, and then there are let's say n terms. And then you will get 2 to the 2n plus 2. minus 1. Okay, by the formula. Okay, so if you let 2n to be 2 to the n to be n, so t of n and t1 plus this is basically n squared. So theta n squared. Okay, so in this case the critical is 1 and this is exponent is 2, right? So this n squared term will dominate the first term. Okay, so this is the 3 examples master theorem. So let's see the proof. So amazingly, it's like a master theorem is just this very easy. Okay, so let's quickly talk about it. So this is the main lemma. So we know that this I from 0 and xi will be xn plus 1 minus 1 x minus 1, right? So this is the junior high school. So if the special case is x equals to 1, then we cannot use this formula. Because x equals to 1, we will get like n plus 1, right? But order is n. If x is larger than 1, then this term will dominate it, and it become xn minus 1 divided by x. So it's x to the power n. It's the same as, the order is the same as x to n plus 1, okay? If x is less than 1, then if n is large enough, then this guy will disappear. So this is just constant, right? So constant order 1, because it's like 1 divided by 1 minus x, so it's constant. So at least it's not exact result, it's just the constant, right? The constant order is 1, the constant is x to the power n plus 1 n. Okay. Okay, so let's see a proof. So let's assume that we have this relation. So t of b is a t of 1. Oh, by the way, so in the computer science proof that people like to use the something called the subproblems. So you can draw a tree, and there's how many subproblems you can get. So this is a usual. So usual computer science people will use the use the different proof as I use, but I think even though you don't know any computer science, you can still do this proof, right? Just brush from your high school technique. So t of b is a t1 plus bc, right? If this is n to a c, and the t of b squared will be a times the previous one, so a squared t1 plus abc plus b2c, and the t of cube will be a cube t1 plus a squared bc plus a b2c plus b3c, and the t of b quartic will be a to the 4 t1 a3 bc plus a squared b2c a b3c a b plus b4c. So obviously you see a trick, right? So t of bn will be a to the n t of 1 plus bnc plus bn minus 1c a plus bn minus 2c a squared and a n minus 1 bc. So just for convenience, I let x to be b to the c. So we get x to the n, x minus n minus 1a, okay, and then you combine all of it, then finally you will get a n to n t of 1 x and 1 plus a over x, a squared over x squared, a to n minus 1 divided by x n minus 1 squared, n minus 1. Okay, so let's say b to the little n will be large n, so t of n, and this n small n is log b n, right? So it's a to the log b n, t of 1 plus this x and all the sum. Okay, so it's use this formula or sum. Okay, so this sum over just this sum just this, right? And this a log bn can shift this n and a. We got this t of 1 plus b to a nc, right? X is b to a c, this. So combine all of its final result will be t of capital N log ba t of 1 plus n of c, a divided by bc to the power I from 0 to n. Okay, so this is our result. Okay, so now we can use our junior high school results. Let's say the first. Okay, so this is a little bit math. So let's see the first case. So the first case is that nc greater than c. So that means log ba greater than c. So a is greater than b to a c. I think everybody agree that, right? So a is greater than b of c means that this guy is larger than 1. So it will become x to the n plus 1. Okay. So for this nc larger than c, we'll get nc t of 1 plus nc this guy, right? A divided by bc log bn. Because it becomes to the x to the n plus 1, so it's x to the power n. And this you can change this, you can fix this b and pull this n down and become n log ba minus c. So this is and then these CC cancel, you get the n of NCT1 plus n of log BA. So you get so these two terms now the same contributions, you get n log BA. Okay. And in the third case that the NC, so the third case is much simple. So NC is less than C, so A is less than B to C. So that means this term will disappear. Sorry, this term will be constant order, T of 1, right? So n log BA T of 1 plus NC. So we get n of log BA T of 1 plus NC, right? Because this term is less than 1, so it's constant. And we know that C is larger than NC, so this result will be theta NC. Okay, so this is the third case. If you follow, so the key idea for third case is that NC less than C, so A divided by BC I will be A divided by BC. This geometric series ratio will be less than 1, so this term will be constant. So we get the theta NC. Okay, so now we see the final trick is that NC equals to C, then it means X is 1, right? So for this. So we only get 1, right? We only get n, so it's n to the NC T of 1 plus n to the NC n. And what is n? N is log Bn, right? So it's T of n is just n to the NC log Bn. So we prove. Okay, so this is the second case. Okay, that's all the master theorems proof, and then we brute force solving 3 stupid example, and then we see that amazingly this main lemma, basically your junior high school intuition of this geometrical series, is just the master theorem. So master theorem, in naively speaking, is just the geometry series in the junior high school. Okay. So I hope you guys love this video. So I try to prove this computer science result just by simple math. So, and I find this way. So there's no, that's it. Okay, and I will see you guys in the next video. Be sure to subscribe to my channel. Thanks.